In the first video, we introduced the GCCT approach to create games with customized tools. In this video, we'll introduce a vocabulary which plays an important role in the approach. In the approach, the first step is to customize game features that will be supported. We use the domain model to formally model these game features, but this UML class diagram may not be straightforward to various games and for everyone. Things can be easier if we have something like a concept pool, where predefined concepts can be used as some building blocks. These concepts should meet the requirements for the overall approach. They should be well known and make participants feel intuitive to use. They should be easy to implement as software codes, and they should be structured to make searching and using them easy and efficient. We call such a set of concepts a domain vocabulary. Developing such a domain vocabulary may not be cheap. In order to benefit the most from such a vocabulary, it is targeted at a bigger and more general domain. Therefore, with one domain vocabulary, we could derive many domain models for various small subdomains. PerGO, meaning pervasive game ontology, is such a vocabulary for the domain of pervasive games. Before we further introduce PerGO, we quickly have a look at what are pervasive games. Pervasive games are emerging during the recent 10 years. Simply speaking, they are computer games that involve more physical elements in the virtual game world. Typical features of pervasive games are like location awareness, context awareness, using wearable devices or physical user interfaces, mobile, and long-lasting. As a domain vocabulary, the concepts within PerGO should be qualified to ease the consequent tasks in the overall GCCT approach. We reviewed more than 30 pervasive games to ensure all important domain-specific features would be supported. We derived the concepts from a smaller set of terminologies that are generally used, such as AI, action, and player proxy. We make sure the logic behind the concepts is coherent and easy for implementation as a data structure, a function, or combination of them like a class. Also, to ease seeking concepts in the vocabulary, all the concepts are organized in a tree, and we can go through the concepts by looking at the 6 parts of the tree in sequence. We call these parts of the tree as perspectives, like gameplay perspective, AI perspective, and etc. If we revisit the previous demonstration of real Pac-Man games, it may be clearer about how PerGO helps us to define the game features for the tools. We go through the 6 perspectives of PerGO in sequence. In gameplay perspective, 2 groups of concepts are included: challenges, meaning what players need to do in the game, and actions, meaning what players are allowed to do to overcome the challenges. Typical actions in the pervasive game can be like physical movement or physical taking a picture of something, while a challenge of finding some object may probably be overcome by a combination of them, moving to an object and taking a picture of it. For AI perspective, some procedure patterns are collected. For instance, we use the follow AI in the real Pac-Man games, indicating an enemy should by default follow the Pac-Man. And in element perspective, Pac-Man as the player proxy and enemy fruits as common visible elements are used. In traditional computer games, keyboards and mouses provide basic but somewhat clumsy means to control the games, while in pervasive games, more advanced control mechanisms are often employed to enable controlling in a more direct way. For instance, a physical touch may invoke in-game actions, and the real-world temperature change may trigger the game world changes. On the other hand, games need to present their internal status to the players. As most traditional computer games use visual means like screens and auditory means like speakers, pervasive games may also employ means of physical or electrical. For instance, physical moving something or sending an email to somebody. What's more, there are some mechanisms which not only accept control but also present game world outside. Real Pac-Man games use a real-world map as well as markers above it to receive location information and to present them to players. As a result, we identified useful concepts in PerGO, made some adaptation if needed, and enriched them with attributes according to the requirements. We could formalize some domain model for real Pac-Man games then. Thank you for watching, and we appreciate your participation in our survey. For any further queries and comments, feel free to contact us.